Teahan.
And I'm Kingston.
Today we'll be presenting you with Shree News. We're presenting you the presidential debate for year 2024.
And we will be first discussing the Big Bang, and we'll be presenting the arguments from the atheist side and the Christian side. So, Schwan, what do you think about the Big Bang?
I think the Big Bang is a very interesting theory. It basically says, if you didn't know, that basically according to Einstein's equations, which is both forward and backwards in time, basically if you keep going backwards in time, all mass tends to approach a single point referred to as a singularity. We do not, at the Planck scale, it kind of becomes inaccurate though, because it's just not designed for it, and there's the question of, is it even hold there? Because we say it approaches a mass of infinity, which is more likely kind of an artifact of what the equations are saying, rather than saying all infinite mass existed at said point. And so we have a question of quantum gravity, will it solve that problem? Because we don't even know if time really existed. There are some theories in physics where they say time is kind of just present as an artifact in order to make sure you have something that keeps things like from contradicting each other. Alright, what are your thoughts on this?
I agree with you. There is a Big Bang, but I disagree with you that it's because of this time and space and starting at the beginning. I believe it is because of
Elaborate.
well, you see, there's this thing called contingency. Yes, time, space matter, gravity, they all had to be contingent upon something. And that something has to have a greater power, therefore, it has to be contingent upon itself. And that is why it's God.
I honestly don't agree with you. I say because there's actually several theories that demonstrate that space-time itself is not fundamental, and therefore time itself is also not fundamental. Which means it kind of could exist outside of time. It could be in its own sense, similar to the idea of God being contingent upon itself. The universe itself is contingent only upon itself in a similar way here in God. Both of them do require blind leap of faith, though, so I mean, both of them hold merit.
I agree.
Hello, Kingston. Tyler. So, second question of the day. What is Wroblewski theorem? What did it say, and what are your thoughts on it?
The Wroblewski. It's one of my favorite theorems. See, there are three main conditions for it to actually work. See, the first one is that space-time must hold in the given point that you're checking.
And the second point is that there's this thing called geodesics. So basically, it's kind of like the thing where you record like four-dimensional space-time, where it allows for free fall or like movement with time or in time.
And the last condition is that the Hubble time must be greater than zero, in which layman's terms basically means that the universe is expanding, in which we've observed that it basically always is.
So there must be. So I would actually like to argue that BGV cannot actually hold true because it's taking in consideration one of the requirements that space-time has to be required in order for the theory to hold true. I would like to argue through there's this thing called loop quantum gravity, which basically explains that time is actually not fundamental, because at some point at the beginning of the universe, there could have been a time where time doesn't even exist at all. So you can't really say there is a finite beginning at all, even though you have the expansion rate over zero.
Well, I do kind of disagree with that. From my research, there are actually some models that prove that time is a fundamental constant that must always exist, and so therefore the Wroblewski theorem must hold true and thus can be used. And again, thus proving that the universe has a start. And see, I feel like this is a good tie into how the Big Bang must be caused by some force greater than us.
Speaking of such models, I've actually heard of this thing called a belief called the Big Bounce, where basically the universe, as is expanding. At some point, it's going to crunch back up down to a single point, and then eventually expand again. I want you to hear your thoughts about that.
Oh yeah, that's just wrong. So to begin, the whole really thing about time is that as time increases, entropy also increases. But the whole idea with a collapsing universe about how it goes down and go back out, the big idea is that would have to have entropy decrease, in which that doesn't really make sense because, of course, this entropy sort of always has to increase with time, in which, of course, if it's getting collapsed, that's entropy going down, which of course doesn't make any sense.
Here I am joined with Andy and Sean. Hello, gentlemen.
Hello.
I just want to ask a question. It is, what is a finely tuned universe, and what are your thoughts about it?
Of course. Well, a finely tuned universe is when all the constants are precisely accurate, that if you change it by even 1/10 to the 120th, the stars would explode and there would be immense changes to our world. And, well, you could say, is this random or was this on purpose?
I personally believe that there are actually very interesting numbers. One, for instance, is the cosmological constant. Amount of accuracy you need is 1 over 10 to the 120th. That means it is a number with 123 zeros at the end, and it's that accurate. And it is interesting to think about, but it also calls into question, really, how likely is it that we have a guarantee that is not just random? Because what is if something else, like another value, was changed, that something else occurred, where life was something entirely different?
Well, that's a great point, except for the fact that to have low entropy, you have to have 1 over 10 to the 10 to the 123rd power, which means it's almost impossibly accurate, where you have to be precise right down to the perfect number. And according to Sir Fred Hoyle, a super intellect has monkeyed around with chemistry, biology, and physics to create the perfect universe for us, and that's why I believe it is God.
Well, there's also several numbers where you have some values like that or correspond to gravity. You might say, well, if you change them, what happens to the universe? Most of them can be changed actually surprisingly significantly to where you can actually still have a universe. The thing is that they just change how it works. So certain constants, if you increase them by, say, 10, stars may just burn out too quickly for life to support, which is definitely interesting. It's very hard to argue against, because it's actually it's just so random that it's unlikely to occur randomly. It's honestly kind of why I'm slightly not fully leaning towards my previously stated side, but I do find it very interesting.
Here I'm with Kingston and Tyler. Tyler, we've heard of the theory bubble multiverse. What is it, and what do you think of it?
Yes, the good old bubble multiverse. So basically, bubble multiverse is kind of like a theory where different universes are expanding and each have kind of like their own properties. For example, here we have like the fundamental constant where like gravity is like a certain number, but it could be a different number for a different universe. And basically, what I like to argue is that BGV, or the Bohr-Guth-Lincoln theorem, can't actually hold for any of them. Because the bubble multiverse is kind of like an idea where, you have different universes expanding out. And pretty much each one has its own properties, saying like, here you have a certain value or constant for gravity. Well, it could be different for a different universe somewhere else. But the point is, the Bohr-Guth-Lincoln theorem still has to apply for each one of them, meaning that each single individual universe within the multiverse has to have some finite beginning.
Well, I do agree with the fact that the universe must have a beginning, but unfortunately I don't really agree with the idea that there's a multiverse.
So, do you have any evidence of that?
Oh yes, absolutely. So, according to Paul Steinhardt, who actually wrote Writing in Nature, he very much states that there's no evidence to actually support the idea of a multiverse. See, he notes that premature hype over gravitational waves highlights gaping holes in models for the origins and evolution of the universe, essentially meaning there's no real way to actually prove or disprove the fact that a multiverse exists. From what we have right now, there's no real way to say that we are living in a multiverse or not, which can only really point to one thing, that there must be some greater being that started everything.
This was Shri News with the 2024 presidential election.
And on to other news, Shri just recently
passed his test.
We're gonna get into that now.
In terms of personal opinion about what the arguments we have discussed in class, I believe Big Bang is definitely an interesting one. The problem is that it's not particularly fully fleshed out in terms of a physical understanding through physics, because we do not just... The singularity is just more so indicative of a error or problem with field theory and Einstein's equations than anything else. And because at the very small scale, we cannot accurately determine what is going on. So we need to understand and develop a theory of quantum gravity. BGV is kind of interesting because when it holds, it does guarantee a start, but the question of does it hold is very present, because it does actually still need space-time to hold, and there are models that do disagree with that it holds universally. So there could be a point before the start of the Big Bang, when there wasn't even a start, or it even wasn't exactly before, because time didn't exist, and that can kind of cause problems. Fine-tuning is definitely the most interesting of them all, because, well, you can get a universe that being oddly perfect is just kind of too hard to just ignore or push to the side. A lot of the numbers do actually have some interesting background to them, but it is also still very if you want to call it, you could call it lucky, but it does actually have probably the question of, is there more? I feel like the best out of everything. And the multiverse is a odd one because it's not a particular popular theory, but it does definitely interesting. Personally, though, I don't think I think this has moved me in a way, but I think I'm still agnostic more so than anything else. That's kind of it, though. I don't really think it changes too much.
Hello. So right now, I'm just gonna give my very quick like personal reflection for this entire video and the entire topic in general. So personally, I'm really just impacted with the idea that a finely tuned universe really does prove some existence of a god. Like, there are many values in the like it's very much values in, like biology, chemistry, physics that simply just have to like be the specific value for things to like still work out. Like according to this, see, the mass of protons are 2,000 times the mass of the electron, but even if it's changed a teeny bit, things simply will not form. Like according to Alistair McGrath, a theologian and scientist, the entire biological evolutionary process depends upon the unusual chemistry of carbon, which allows it to bond to itself as well as other elements, creating highly complex molecules. See, like, if these types of like combinations and types of like numbers didn't exist, these very specific numbers, nothing would really work out, and life simply just wouldn't exist. See, even according to agnostic Steven Weinberg, a Nobel laureate in physics, he said that it's surprising that the laws of nature and the initial conditions of the universe should even allow for the existence of human beings who could observe it. Life as we know it would be impossible if any one of several physical quantities had slightly different values. Even agnostic people, like even like very famous scientists, even still understand that these values are very specific and that one small change would not allow life to simply exist. I feel like that's one really good, and that's one thing that's really impacted me personally, that there must be something bigger than us that's really controlling everything. That something real, that some God. I mean, I want to say God. I don't know if I really can, but there's some big being that seems to be starting everything, and that's really making this life for us.
As I explored more into the primary reality of God's nature, I found it more convincing that he is actually real. And I found this through the fine-tuning most of the time. And the reason is because with the fine-tuned universe, it has to have someone who's extremely intelligent beyond our understanding of how those numbers correlate to different things. And we also see that the universe has to be created by those numbers, and therefore it has to be someone supernatural or something supernatural. And that's why it goes back to Aquinas, where it has to be the uncaused cause, the unmoved mover. These line up where it makes sense to as why God is real and how it connects with the fine-tuned, the multiverse as well, and each of his 3 ways or his 4 ways.
So one thing in particular I've been thinking about throughout this like capstone is whether what we observe in the physical universe actually connects us with Aquinas's philosophical arguments about God. Particularly in the Big Bang and the Borde-Vilenk and Gu theorem, both kind of suggest that the universe had a beginning. If everything that begins to exist needs a cause, that seems to kind of point toward something outside of the universe that brought us into existence, which kind of brings us to Aquinas' idea of an uncaused cause. Additionally, like the fine-tuning problem also kind of stood out to me because like the physical constants of the universe appear extremely precise for life to exist. Some people would explain this through like the multiverse, but like for me, the idea itself isn't actually observable. So like it kind of involves a little bit of faith in that statement. Overall, what this kind of made me realize is that both like atheists and theists rely on like assumptions beyond what science alone can prove. For me, the idea of like a purposeful cause behind the universe resonates more like with the evidence. But, you know, I still have questions about, you know, what the nature of that cause is and what like God really is and what his role is in creating us.